So we're going to carry on with question 2 on geometric reasoning, and this is your PEA exam number 1, so practice exam 1. Okay, taking a look at this, we have a regular octagon. So regular, what does that mean? That means that we're going to have equal lengths for the sides, and what else? Equal angles. So it's kind of saying there's a lot of symmetry in this. Each of these interior angles is going to be equal, and each of these lengths will also be equal. Alright, calculate AOF. That's this guy over here. AOF. Calculate that angle and give reasons for each step. Okay, start with what we know. Octagon has how many sides? Octagon has 8 sides, so if you want to, we could figure out how big each of these angles inside the octagon is. So, interior angles, our generic formula for that is 180 times n minus 2. And again, n is equal to the number of sides. And there are 8 sides. Octagon means 8, but you can count if you don't believe me. 180 times 8 minus 2. So that's 180 times 6, which is equal to 1080. So in total, inside of this octagon, there's 1080 degrees to be split up equally between the 8 angles, because they're all equal angles. So if we want to find the size of one interior angle, we can do 1080 divided by 8, because they're split up equally. So 1080 divided by 8 gives you 135. So I know each of these angles is 135 degrees. Okay, so I've got 135, 135, and because this is at the center of the octagon, we can assume that it's splitting these angles in half. So what's 135 divided by 2? 135 divided by 2 gives you 67.5. So we could say that these are 67.5. Just the inside bit, 67.5. So, if I kind of take another look at this shape, I have a regular octagon, but what else do I have? Remember, we can use this formula for the interior angles of a polygon for any polygon. So, how many sides do I have on this yellow polygon? I've got 1, 2, 3, 4, 5. Not that they're equal, I'm just counting them off. So I've got 5 sides. So how many interior angles am I supposed to have total? You'll notice I've found this angle. I know that one, I know this one, and I know this one. So I'm only missing the one angle, the thing I'm looking for. So if I know how many total, 180 times 5 minus 2, that's going to be equal to 540 degrees. So in total I should have 540 degrees interior inside of this octagon. And I know what I have, so I'll subtract those away. So angle AOF is going to be equal to 540 minus 135 minus 135 minus 67.5 minus 67.5. So angle AOF equals 135 degrees. So I've used 2 polygons here, the original octagon to figure out information, and then I've used a smaller pentagon, a 5-sided shape, to figure out the interior angles for this yellow one here. And using that information, I'm able to solve for the actual angle they're looking for, AOF. There is another way you can look at this problem, though, if you like. One other way to visualize this situation is kind of by breaking the octagon into equal little wedges. Okay, so I know these lengths that are pink, those will be equal. So we get little kind of isosceles triangles forming in here. And one thing that I can figure out is that angles at a point are adding up to what? Angles at a point equal 360, so 360 degrees at a point. And because this is a regular polygon, so everything's going to have symmetry, how many wedges do I need to break that 360 degrees up into? 1, 2, 3, 4, 5, 6, 7, 8. 8 wedges. So 360 divided by 8 will give you 45. So I've basically found that I need 45 degrees on each of these angles at this point. And how many of them make up the angle AOF that we're looking for here? There's 1, 2, and 3 of them. So 45 times 3 gives us 135 degrees. Angle AOF equals 135. Two ways to solve the problem, just depending on which way you see it. Both are correct. So, looking at the last part here, D, this big shape is a pentagon, meaning 5 sides, which is symmetrical about the line AF. Okay, so about the line AF, if we draw a line then through A and F, just so we can visualize what they mean. Just kind of dot it on there a little bit. Symmetrical about AF, that means that these are mirror images, so both sides are equal to each other. So that basically means the angles that we see over here will be equal to the angles we see over on the other side. So using that, we're going to look at the x, the angle they've given us. X here is going to be equal on this side due to symmetry. So that seems like a good point to start at. We're wanting to find, what are they asking for? Angle FDC is equal to x, and they want us to find an expression for EFB. EFB. They want an expression for this angle here in terms of x. Okay, so we need to give our reasons for all of this. Angle FCD, this one here, is equal to x, and the reason here is due to symmetry. They're mirror images of each other. If you fold the shape in half along the AF line, those two angles will be lining up identically with each other, so they will be equal. And what else do we know then? Using the idea of symmetry, this line here will also be equal to this line here. So what kind of triangle do we have? We have an isosceles triangle right here. So we can solve for angle DFC because we know the base angles of an isosceles triangle are equal, x and x, and all up we need to add to 180 degrees. So 180 degrees minus the base angles, x and x, that's 2x, is going to give us this angle here, DFC. But what do you notice about angle DFC? What else is it equal to? Hopefully you see it. Angle EFB is equal to angle DFC. And my reasoning for that is these are vertically opposite angles. Okay, so since they're vertically opposite angles, they're equal. So angle EFB then is equal to 180 minus 2x. Oh, I hate it when that happens. Okay. So here we go. That's our answer. Angle EFB is equal to 180 minus 2x because we solved that down here. An isosceles triangle has 180 degrees in it. So if I want to find this top angle here, that's 180 minus x, or 180 minus 2x. And these are vertically opposite, so they're equal, and we know that angle.